Okay, here's the second video, and now we are going to do complex fractions involving monomials. Now, you definitely can use like a formula to be at the end of this, but I like to understand this. So as I have x squared y squared over a, I like to draw that numerator's fraction bar way more narrow than this fraction bar, because that helps me see that we have a fraction up top separated from a fraction in the bottom. So I'm a fan of doing what I did in the last problem. And what I mean is I can multiply this by the reciprocal a cubed over x squared y. But I can't just change that. I can also multiply this by a cubed over x squared y. And the reason I chose those values is to get rid of the fractions being in the denominator, so that I now have this entire thing x squared y squared a cubed over x squared y a. And on purpose I wrote that in that order so that they would be descending, starting with x squared because that's more common, and then a. I know a is alphabetically earlier, but that's the decision I made there. Now head to simplifying. X squared over x squared is bye-bye. Y squared turns just into y up top, and then a cubed turns into a squared up top. So that in all of this, it's tempting for me to only write a squared, so be careful to make sure you include that y as well. Now how cool is it that all that hideous stuff turned into something so simple? I know you're excited. So here's g cubed h, written small again, that smaller fraction, over b, and then g h cubed I, which is a weird letter to have to write inside of this, b squared. Same deal as before. I know that by multiplying the denominator by its reciprocal, b squared, and then g h cubed I, it'll go away. And then up here, b squared, g h cubed I. So then I go through b squared goes away, gh cubed I goes away. And, really you don't have to rewrite this step like I did. So let's jump right in, canceling out this b with that exponent of 2, g cubed with g leaving us with g squared, and then h with h cubed leaving us with 2, and I don't see anything that's going to take care of that I. Now maybe you see why I did show that extra step here. There's a lot of crossouts that are probably making this a little bit messy. Here's g. I scan through the top, I see g squared. I scan through the top, I also see b. And then in the denominator, I see h squared, which is so hidden I almost didn't write it, and then I. So as I go through this, my eyes are kind of retracing what went away, making sure I didn't forget anything. Same deal here, we got that g squared showing up, b showed up, and then h squared and I showed up. So I'm just giving you that extra explanation to make sure that we're being thorough in our work. Okay, there's no negative exponents or anything going on, but we do have a negative value in the front of this one, so we'll do another one. You can OYO this, but then still listen to this explanation if you want to see if you're feeling comfortable. But I'll start talking about it as soon as I finish rewriting it. My exponent got a little ugly there. Okay, I got negative 24m cubed, n to the 5th, p squared q in that denominator, 16pm squared over n to the 4th cube. Okay, I'm going to multiply both the top and the bottom by n to the 4th over q. Now, I remember when I was first learning this stuff, I was really like pushing the boundaries of what I understood with fractions. And I gambled a lot. Like I tried things out, and by seeing if real number values ended up working out the same, I actually taught myself a lot of this on my own. Okay, we've multiplied by the reciprocal down here, so it all went away. And up top, I'm going to have negative 24 over 16. This time I'm going to rewrite it all. Really does make it a lot simpler. More steps, but definitely more simple. And this one, I'm not even combining everything yet. Your order doesn't matter. Alright, let's see what I can get rid of. I see m cubed and m squared, so that leaves me with m to the power of 1. I see 24 and 16, which leaves me with 3 over 2. I see q and q. And if you leave anything out, you can just go back and complete it in an extra step. So I have m times n to the 9th, and then p cubed with a 2 out front. And unless I made a mistake, that should be accurate. The reason I'm saying unless, it feels a little strange to get n to the 9th when things were canceling out, but there's no reason that they wouldn't give us a problem like that. And as I think about it, well, here's me getting that. I think I'm okay. I think it is all accurate. Oh, that's annoying. I just realized I gave myself all this extra space to work with that I didn't use. Okay, we got 6 minutes 25 into this video. Nah, we will not make this a new video. We'll keep it in the same one. Amazing. Okay, simplify each expression. Complex fractions involving polynomials. So now it's all building up towards something a little bit more challenging, right? I think these are the kind of problems where I really strongly suggest you figure out a way you like to do these. I mean, I guess we could just do what we did before, right? Multiplying by the reciprocal. Or I could, break this into a fraction and break this into a fraction, which might be the easiest. Or I could, combine the numerator just to deal with a plus 3 later. But I think I will break this one into 2 separate fractions. And this requires a little bit of a more comfortable understanding of fractions. I do believe that this is being divided by a plus 3. So I have no problem rewriting that as a over a plus 3. I also believe that this is being divided, but I'm going to try to convince you that I can just simply tuck that right there. Isn't this whole quantity being divided by that? So is there really an issue with me just tucking it there? Also, pretend if I would have multiplied it by 1 over a plus 3. Well, if I multiply the denominator by that, wouldn't I just be multiplying that by 1 over a plus 3? And now I can clearly see that that's getting tucked in right next to a minus 2. So as I wrote this, I'll move on with my minus sign. And next I'm going to write 15 over a minus 2, but I'm going to place a plus 3 here. Now I have that whole common denominator issue, so I need to multiply the left fraction over a minus 2. Sneak some parentheses around a plus 3 to make sure that doesn't get tripped up. Now we have the same denominator, and I'm not going to multi-step that subtraction, but I will distribute in the same step. Okay, so we have a squared minus 2a minus 15 over a minus 2, a plus 3. Now I'm looking for the factors of negative 15 that add up to negative 2. And I'm thinking of negative 5 and positive 3. And I think that works out, doesn't it? These videos aren't really interactive, so you can't tell me yes or no. I'm glad I asked anyway. So there's the factored numerator over the factored denominator, and lo and behold, the glory of math will overcome all. Those go away, and I'm left simply with a minus 5 over a minus 2. Amazing. Okay, we got another ugly creature in problem 2. Let's see what this beast beholds. Rewrite the original problem. So I got b over b plus 3 plus 2 over b squared minus 2b minus 8. I think that factoring this as an early step is going to be nice. And since I'm factoring it, I think in this same problem, I'll go ahead and try to get a common denominator. I mean, we're going to have to do something along those lines later anyway. So I'll get a common denominator for my numerator, so I can put those two parts together. I just think it's going to make it easier. Like I said, I could be wrong. And then in the denominator, I'm going to have factors of negative 8 that add up to negative 2. So I'm thinking b minus 4 times b plus 2. I'm distributing that in my head, and it does check out. Now, before I start messing around with this complex fraction, I'm going to end up rewriting the numerator as 2b plus 6. That's my right fraction, plus b. Now, these b's look like 6's, so make sure you're clear with where I'm pulling 2b plus 6 from, and make sure you're clear with where that b came from. All over b plus 3. Now, if you are a definite believer, then you might want to throw that other fraction here. But just in case we're still not there yet, I'm going to write a large fraction of b minus 4, b plus 2. Now, I'll combine what I have in the numerator, so it's 3b plus 6 over b plus 3. Now, in my head, like I did in the last one, I'm picturing this as the reciprocal, and then this as the reciprocal, and I'm like, guess what? I just kind of taught myself something new. I have no problem just sneaking this in there. But don't jump to that if you're not confident with it. Like I said in the last notes, come talk to me if any of this feels off, because you want to have as deep and rich of an understanding of fractions as the next hero in the room. 3 times the quantity b plus 2 is the factored form. I got b plus 2, which I'll write out front just because 2 is greater than 3 is greater than 4. These guys go away later, and I'm left with 3 over b plus 3 times b minus 4. Not too crazy. Actually, it's pretty challenging, so I don't want to downplay it too much. Hey, look at this ugly guy. Let's make this an OYO problem. And see me if you want to have it checked. But this is also kind of a cool challenge to type into Wolfram Alpha accurately, so give it a try. Now, you don't get Wolfram Alpha on a test, right? But you could actually plug values in there, like try c equals negative 8 or something, and then do the same thing for whatever simplified result you got. And if you choose something random like negative 8, I think you can probably feel pretty confident that you made the right changes in there. Here's the assignment that goes with that. Not quite as crazy numbers of problems. And the reason for that is that these are a little bit more challenging. They're going to involve a couple extra steps.